thought I would do number 35 just because it looked a little strange and just talk about what you'd have to do there. 35 says f of x is equal to 3x cubed plus 4x times x minus 5 times x plus 1. To be honest with you, the easiest way to do, you could use the product rule on all this if you wanted to. If I were going to use the product rule, here's what I would do though, just so you could end up using the product rule and then using the product rule again, but let's do this. What if I did this? What if I said the 3x cubed plus 4x? And then let's say this is function number 1, you know how in the product rule you got two functions multiplied by each other. What if I went ahead and for my second function I went ahead and multiplied this one together? Because if you don't, you're going to have to do the product rule with two of them, get a result, take that result and do the product rule with another one. And I think it'd be a whole lot easier if I just take care of going, you know what, I'm going to rewrite this function over here. I'm going to rewrite x minus 5 times x plus 1 as its own little function together. I'm just going to take it out of factored form and multiply it out. That would be what x squared when you distribute plus 1x minus 5x would be minus 4x. And then negative 5 times 1 is a negative 5. It's hard to read, but that's an x squared. Now I'm going to use product rule. I didn't want to have to do the product rule and then do the product rule again. That would just get too confusing. So we look for ways to kind of work smart, okay? So if I want to take the derivative of this, if you remember, the product rule says it's the first function, which is 3x cubed plus 4x, times the derivative of the second function. Well, the derivative of the second function would be, okay, the derivative of x squared is 2x, the derivative of negative 4x is negative 4, and then derivative of a constant like negative 5 is just 0. Now I got to add in the second function, which is x squared minus 4x minus 5, times the derivative of the first function, or the function I underlined in red over there. That derivative would be 3 times 3 is 9x. Subtract 1 from the exponent would be squared. The derivative of 4x is just 4. So this is my derivative. And again, the fun part in calculus is that it's in the algebraic simplification here. So let's see what this is, because this should work out to be a nice looking function if we just take the time to simplify here. Okay, so that's going to be 6x to the 4th minus 12x cubed. I'll just list all these terms. Then plus 8x squared. And then minus 16x. I'm going to go ahead and do the other one in green just so we can see the difference in case I get lost and have to go back. I'm going to distribute 9x squared over this one here. I'm just going to actually do this two terms over the three terms. 9x squared times x squared would be positive 9x to the 4th. 9x squared times negative 4x, 9 times negative 4 would be negative 36, and then there's x cubed because there's a total of 3 x's. 9x squared times negative 5 would be negative 45 x squared. Now I need to distribute the 4. Actually, I'm going to change color even on the 4, just so if I make a mistake, I can find it. 4 times x squared is, I'm just going to keep adding terms here, plus 4x squared. 4 times negative 4x is negative 16x. And 4 times negative 5 is negative 20. And I just need to clean this up. I'll write my answer in black here. Let's go look. And there's 6x to the 4th, 9x to the 4th. That'd be 15x to the 4th. Okay, mark those out. Then let's look at cubes. That's positive 12x cubed, and that was a negative 36x cubed. So 12 minus 36x cubed would be minus 24x cubed. Okay, took care of the cubes. Just looking for squares now. I've got, I'll use the yellow, I've got 8x squared and minus 45x squared and plus 4x squared. So 8x squared and 4x squared would be 12x squared. 12x squared minus 45. What's 45 minus 12? 45 minus 12. 3. It would be minus 33. Let me write it in blue. Minus 33x squared. Okay, that takes care of the x squared terms. Hopefully I didn't mess that up. And then for the x's, I have minus 16x, minus 16x, That's all of those I see. I don't see any more just plain x terms. So that's minus 32x and then minus 20. So there's my derivative right there. Okay, I'm going to try to fit 45 on here too. So if I'm going to take the derivative of this, let me rewrite the function first. G of t is t to the 1/4 power. That'll help me use my little power rule. And then plus 8 secant t. Excuse me. Okay, we don't really need any product rule here or quotient rule, because if you think about this, all I got to do is take the derivative of each term separately. So I'll kind of color code that. The derivative of t to the 1/4 would be drop the 1/4 down, then you got your t, and then you subtract 1 from your exponent. So 1/4 minus 1, which would be 4 over 4, would be negative 3 over 4. Okay, I'll make that look prettier here in a minute. Now the 8 secant t, remember, it's just going to, when I take the derivative, it's just going to be an 8 out front of the derivative of secant t, because 8's just a constant. And if you look on page 123, the derivative of secant of x is secant x tangent x, so this would be secant t tangent t. Okay, so all I got to do is really clean this up. They gave us a radical when they gave it to us, so they probably want it back as a radical. So it would be 1 over 4. Now that 4, I'm going to move the t to the negative 3/4 means move that term to the bottom. That's what the negative exponent means. But if you remember, the bottom of the fractional exponent tells me I'm taking the 4th root of t to the 3rd power. The numerator tells me what power I'm raising it to, plus 8 secant t tangent t. So that's all you're doing there. Okay, I thought we'd look at 53 next. 53, the equation is 2x sine x. Can't tell it from the iPad, but if you're looking at the problem of the book, plus x squared cosine x. Okay, I'm going to have to do the product rule. I'm going to have to do it twice because each term is going to require the product rule, so let's get going. If I take the derivative, we'll look at the first term. I'll write the first term in green just so we're, kind of color coding this so you can follow. Product rule says I'm gonna look at 2x as the first term and sine x as the second term. So it's the first term, 2x, times the derivative of sine x, and the derivative of sine x is cosine x, plus the second term, which is sine x, times the derivative of the first term. Derivative of 2x is just 2. So I'm just going to go ahead and simplify this part of it. So that's 2x cosine x. We don't need the parentheses. Plus 2 sine x. Okay, that was just the first term. Now let's go look at the second term. I'll do it in like a purple. So I'm going to do this x squared cosine x. So what I have to do is we're going to look at x squared as the first term and cosine x as the second term of the little one term here. Okay, so it's the first term x squared times the derivative of cosine x. The derivative of cosine x is negative sine x. Plus the second term, which is cosine x, times the derivative of the first term. Well, the derivative of x squared is just 2x. Okay, so let me write that down. That's minus x squared sine x is how I'm going to write it. Excuse me. Plus 2x cosine x. Now, we got some like terms here that we could kind of simplify, so I'll go back to blue now. I've got 2x cosine x, and I've got 2x cosine x, 2x cosine x plus 2x cosine x. 2x cosine x plus 2x cosine x, let's say it that way, it would be 4x cosine x's. Let me write that where you can read it. 4x cosine x's. I'm looking at the like term as the x cosine x's, and I'm saying I've got 2 of them, and 2 more of them make 4 of them, if you're confused at all. And then I've got plus 2 sine x. Minus x squared sine x, and if the terms are listed out of order with the key, it really doesn't matter, okay? But there's our answer for 53.